So we have some questions here using vectors coordinates. So stay tuned and let's go through this so you can better understand the concept of vectors. So the first one we have is a point O, 0, 0. So if I was to put that as a coordinate right here is 0, 0. So I can call this particular point O. We have a coordinate f as well at -5, +9. So that would be the x-axis first, so -5, which would be right here, and it goes all the way up to +9. So we can call here f. So the next thing we have is g, 7, 3. So 7 on the x-axis, and then 3 up on the y-axis, which would put us right here. So this here is g. So from this point O straight to f. Alright, so we got vectors O to F. Now how do we write this as a column vector? So this shows that we're going from O to F. As you can see, we have O going to F. Now if we are going to do that, we have to, this means that we are starting from O and going to F. So we always move left to right first. So if we want to go from O to F, I have to go 1, 2, 3, 4, 5. Okay, so because I have to go 5 to the left, writing that as a column vector, I would have -5. Okay, because I'm going left, it's negative. If I was going right, I would have written +5, but because I'm going left is why I wrote -5. Now I have to go up. Now going up would be positive and going down is negative. 2, 3, 4, 5, 6, 7, 8, 9. So then going up is 9. Alright, so this as a vector, a column vector, would be -5, 9. Now because we're starting from the origin from O to F, this is how we knew we could have used this information to help us actually write the column vector, because anything that's coming from O is considered a position vector. So therefore, whatever the coordinate for that is, which would be -5, 9 for F, that would be the column vector as well. Alright, so the next one that we want to do is O to G. So based on that principle that I just explained, that means O to G would be 7, 3. It would be 7 to the right because it's positive and 3 up. Okay, 7 to the right and 3 up. So let's just test this out on our little diagram here. So we're starting at the origin now. We're starting at the origin and we're going to G. So we're going from O to G. So we go 1, 2, 3, 4, 5, 6, 7. So 7 to the right. So that's a +7. And then we go 1, 2, 3 up. So that's 7, 3. So from O to G is 7, 3. So that's the first two. Now we need an expression for FG. F to G. So I'll show you two ways of doing it. So if we're going from F to G, we can work it out using this diagram. But the question is, what if we did not have this diagram? How would we do it? Now you have to think of F to G as a pathway, but think of this pathway that passes through O. It has to go through O. So kind of think of this as a roundabout. So imagine F here was a location on the roundabout, and we are going from F, and the roundabout itself represents O. So the center here is like O. Now we want to get to G, which say is another point somewhere up here. Let's just say this here was G. Now in order for us to get from F to G, we know that there is a point that goes from O to F, right? Just like we have O to F here. And we also have a point that goes from O to G here. So when we are looking at this, we could look at it from the perspective of we're going from F to O, passing through the roundabout. So F going to O, and then from O, we go to G. So we could say that for C, what we're actually doing is F to O plus O to G. Now this here starts at F. Think of it like a transition or flight. Fly from a point F to O. You catch a transition flight from O to G. So in all, you're actually going from F to G, but you took a little extra path to get there. Now we have OF. OF is -5, +9. So FO would be the inverse of that. So basically FO would be 5, -9. If we look at our diagram just for reference, if we're going from F to O, we will go 1, 2, 3, 4, 5 to the right, which makes it +5. And then we have to go down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And because we have to go down 9, that's why we call it -9. So that's just to give you a reference as to what FO would really be. So then now the same concept for OG, we have OG already, which is 7, 3. So we're just going to add that 7, 3. So 5 plus 7, we add the top numbers, gives us 12. And then -9 plus 3 gives us 6. Therefore, FG can be represented as 12, negative 6. Now, if you wanted to do this using the graph, and that's in a case that you actually had a graph or you sketched one, we want to go from F to G. Because we have the coordinate sheet, we can actually go straight from F to G. So in that case, I'm moving to the right or left first. Remember, we're going left or right first, and then we can go up or down. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we are right above G. So we had to go 12 to the right. Now we have to go down. So we go 1, 2, 3, 4, 5, 6. So we had to go 6 down. So that would be negative 6. So therefore our vector from F to G would be 12, negative 6. Alright, so let's look at part D. So part D here, it says L is a point on FG such that FL, LG would be equal to 1 to 2. So what we're saying here is that we have a line F to G. So here is F and here is G. Now somewhere along this line, the point L would be located along that line. So somewhere along this line here, we would have the point L, somewhere along this line. Now, how do we know where L is? Well, they gave us a ratio. So they're saying that FL to LG can be represented as 1 to 2. So let's think of it this way. If FL takes up one portion of this line and LG takes out 2 portions of this line, together they have 3 portions. So let's put it in a sense of a chair. So let's think of these as chairs. So we have 1, 2, 3. So I got this 3 because of the 1 and the 2 here put together. So 1 plus 2 is 3. That's how I got these 3 chairs. Now we're saying that FL represents 1 chair and L to G represents 2 chairs. So my point for L has to either go here or here. Which one do you think would be the position L would go? So because FL has 1 chair, I would put L right here. You see? So F to L has 1 and then L to G has 2. So now I need to find a vector for F to L. So now F to L I can say is what? FL represents 1 portion here. So we have 1, 2, 3. So FL represents 1 portion here out of 3. So FL is 1 out of 3 times FG, because look at this, the full line FG, it's FL, that's 1 portion of that entire length. So FL is equal to 1/3 of FG. So what is FG? We already worked out FG here. So then we can work out what FL would be. So FL would be equal to 1/3 multiplied by 12 minus 6. We call this 1/3 the scalar multiple. So this here is being multiplied to each of these. So therefore we would say 1/3 and then 1/3 times negative 6. Okay, so 1/3 times 12 is the same as saying 1 times 12, then 3 times 1 is 3. So it's the same as saying 12 divided by 3, which gives us 4. Okay, so 1/3 of 12 is 4. And then 1/3 of negative 6, that's 1 times negative 6, which is negative 6. And then negative 6 divided by 3 times 1, which is 3. Negative 6 divided by 3 gives us negative 2. So FL can be represented as 4, negative 2. 4, negative 2. So just to put it on our diagram, if we move from F, 1, 2, 3, 4 to the right, and then 2 down, 1, 2, that means our L point would be right here. So this represents L. So remember, we are only just using this diagram here to help us visualize what we are doing over here. Alright, so we've done that now. Now it's time for LG. So LG. Now with LG, we already know that LG represents 2. Okay, so LG represents 2 out of the 3 chairs of FG. So LG represents 2 out of the 3 chairs of LG. So 1, 2. So therefore, we can say that LG is equal to 2 out of 3 FG. So 2/3 of FG. Now we know that FG is 12, negative 6. Alright, 12, negative 6. So I have to multiply 2/3 to the 12 and then 2/3 to the -6. So let me just show you here as a fraction, 12 over 1, -6 over 1. So 2 times 12 is 24 over 3 times 1, which is 3. And then we have 2 times -6 is -12 over 3 times 1, which is 3. This would simplify now to 24 divided by 3 is 8, and -12 divided by 3 is -4. Okay, so LG is 8, -4. Now, if you think of it here, let's look at L here going to G. So in order to get to L from G, we move from L, go right first, 1, 2, 3, 4, 5, 6, 7, 8. Then we go down 1, 2, 3, 4. So because we went 8 right, that's how we get +8, and we went down 4, which is -4. Remember, I'm only using this to show you how this works visually in an event that you did not have this here while doing the question. So with question F, we have to prove that vectors FL and LG are collinear. So in order to prove that something is collinear, they must be scalar multiples of each other. Now the question is, what does that mean? So let's say we have LG. So LG is 8, -4. And we also have FL, which is 4, -2. So as you can see here, it's like these here have some kind of relationship, because 4 multiplied by 2 would give us 8, and -2 times 2 would give us -4. So the scale factor here is 2, okay? So in essence, if I was to divide the corresponding coordinates, the corresponding components together, I would say that 8 divided by 4 is equal to 2, and then -4 divided by -2 equal to 2. So because two of these are the same, I know that they were multiplied by each other in some form. So therefore, in this case, for instance, that means LG is twice the size of FL, okay, because both of these values had to be multiplied by 2 to get this here. So in essence, so now that we know that they are scalar factors, we need to see if they share a common point. So FL and LG, what common point do they share? The common point that they share would be L. So both of them share L. So because they share L, they're considered to be collinear because they are scalar multiples of each other and they share a common point L, thus they are collinear. If they did not share a common point, we would have said they were parallel. As you can see here from the diagram, we have FLG on the same line. All we mean by collinear is that they're kind of on the same line. They form the same line, same direction. It's one continuous flow. Okay, so we know that LG and FL are collinear because we just proved that they're scalar multiples of each other and they also share a common point L. So the next question is, determine the column vector for OL. So we want a column vector for OL. So similar to how we did F to G, we need to determine how can we get from O to L. So we have a visual representation here. We have O to F. So let's say we had O here, then we have G here, and we have F here, and somewhere along F to G, we have L. So the question is, how do you get from O to L? So if we're going from O to L, we have to go O to F, and then we have to catch a trip from F to L. So it's going to be O to F plus F to L. So if you notice here, we're going from O to F, F to L to get to OL. These are like roads that we have created. So do we know what OF is? Yes, we do. So OF is -5, +9 plus FL. Do we know what FL is? Yes. We worked out FL earlier, which was 4, -2. So then now we can say -5 plus 4 is -1. And then we could say 9 plus -2 is +7. So OL is -1, +7. So let's try that differently with our other direction, because we could go O to G plus G. So O to L can also be written as O to G plus G to L. So do we have OG? So OG, yes we do, which is 7, 3. And we also can work out GL because we have LG. So all LG would be is the inverse of GL, similar to what we did with OF. OF was negative 5, 9, which meant that FO was 5, negative 9. We just changed the signs. If we have LG being 8, negative 4, then we should have GL being negative 8 plus 4. Because this minus 4, so then now we could add these together. So 7 plus negative 8 is negative 1, and 3 plus 4 is 7. So negative 1, 7, negative 1, 7. So OL is negative 1, 7. And we could also look at it from our diagram. So if this is O and we're moving to L here, we go 1 to the left, which is negative 1. Then we have to go up to get there. So it's going to be 1, 2, 3, 4, 5, 6, 7. So we had to go 1 to the left and 7 up. Other words, negative 1, positive 7. So determine the coordinates for L. So for L, if we know that O to L is negative 1, 7, remember O meaning that it's starting from the origin and goes to the point L. So from O straight to L. Because of that, we know it's called a position vector. It's a position vector. So all we know that position vectors start from the origin and go to that particular point. So if I have a position vector, that means that the coordinate negative 1, 7 would be for L. So therefore, L is the same as negative 1, positive 7. And as you can see from our diagram, we have negative 1 here and it goes to 7. So the coordinate for L is negative 1, 7. Alright, hopefully you learned something from watching this video about vectors. Just continue to review it, go over it as many times as you need to. It's very important to repeat. If you repeat it over and over, you'll understand it better. So continue to practice, continue to work hard, and good luck in whatever you're preparing for. Just remember, this ain't no play man thing. Stay focused, stay locked in, be smooth.